Okay, good morning, Algebra 2. Some people have mentioned that they couldn't find chapter 5.5, so I thought I'd just do a quick video on it. The notes are attached in your classwork under chapter 5. This is solving polynomials by factoring. So when you were given quadratics in the last chapter, the whole point of factoring was to find your x-intercepts. So we're going to factor. We ask ourselves first, is there a GCF we can take out? There is not. So we're going to factor this trinomial where a is 1. So we look at the factors of 10. 5 and 2 will give us 3. But we'd need a -5 and a +2. And then to find intercepts, you set your function equal to 0. And the zero product property says if you factor the polynomial and it equals 0, then each factor can be set equal to 0, and then you can solve. Okay, the next one is special cases. So just as quadratics are factored as a product of two factors, a polynomial of a higher degree, like x cubed or x to the 4th, is factored by writing a product of more than two factors. So I'm just concerned about factoring right now. The whole goal is to factor so that you can eventually set the pieces equal to 0 to solve. So I just want you to factor for right now. We see here that there is a GCF of x, and that when you remove it, you're left with x squared minus 9. But then, I mean, you could just set these equal to 0 and solve, but the more you factor, the easier it is to see all your zeros. So part B, it says to find the zeros, set each piece equal to 0 and solve. Okay, so if you're to the third power, you should have 3 answers. Just like number 2, you're to the third power, you should have 3 answers. If there's 4 terms, something should kind of go off in your head. You're going to group the first and you're going to group the last. There's not an overall GCF. But if you look at the first 2, you see that you share an x, and if you look at the last 2, your GCF is 2. So you've now created an overall GCF. So by looking at the GCF for each one, we now have a GCF between both, which is x minus 1. When you factor out or remove it, you're left with x squared plus 2. You set each piece equal to 0 and solve. Now, you're not always going to have, so you'd get to this part, you'd say no solution, but we know better than that because in chapter 4, we dealt with complex solutions, and that's what we have. Do we have 3 answers? Yes. We actually cross at 1, and then we don't cross again, so we have an imaginary solution for when we're solving algebraically. And then number 3, you take out a GCF if possible. You factor like normal. So you're going to get 0, you're going to get 8, and you're going to get 8. Now I like this example because you see 8 twice. Okay, that's called a double root, or your answer is 8 with a multiplicity of 2, meaning your answer appears twice. Now what does that look like graphically? And at this point in class, I would have you graph this in your graphing calculator, and I'd walk around and make sure you graphed it all right. When you graph it at 8, 1, 2, 3, 4, 5, 6, 7, 8, does it actually go through 8 twice? No. Answers like this means it would either touch 8 and keep going, or touch 8 and keep going. It wouldn't actually go through. It would be what's called tangent. I'm sure you've heard that word. Tangent means touching at one point. So if your answer is 8 twice, that means that your graph simply just touched 8 and kept going. It didn't go through. Okay, so that's why you get the same answer twice. Now, you've dealt with the difference of 2 perfect squares, but there's also something called the addition of 2 perfect squares and the subtraction of 2 perfect squares. The patterns are the same, exact same, but for addition, it goes plus, minus, plus, and for subtraction, it goes minus, plus, plus. Okay? It says factor the polynomials and find the x-intercepts. So if we factor the first one, you take the cube root of x cubed, Well, if I cube x and I uncube it, then I get x. The cube root of 125 is 5. The pattern goes, you square a, then you'd square b, and then you multiply the two together. So if I square x, I get x squared. If I square 5, I get 25. And if I multiply them together, I get 5x. And then since it's plus, the pattern goes plus, minus, plus. There's always going to be two pluses and a minus. Here, x and 3, square the first, square the last, 3x. Subtract the first, plus, plus. And then the last one, square root, or I'm sorry, cube root, square, square, multiply together, plus, minus, plus. All right. If you set each piece equal to 0 and solve, what will you get? So you get -5. You'd have to use a quadratic formula. 3. You better use a quadratic formula. -10. And use the quadratic formula. Okay. So if x minus r is a factor, then r is a solution. Okay, it's called the factor theorem. So x minus r is a factor of a polynomial if and only if x equals r makes the expression equal to 0. So whenever I can't understand something in mathematics when I was your age, I would replace r with a number. So if I have x minus 5, let's say, that is only a factor if x equals 5. Okay, so for an example, in the function, x minus 3 is a factor because if I substitute in 3, I get 0. Okay, now this is going to take us to chapter 5-6, solving polynomials with that last step. Okay, and I'll post a video of that.